Hi, welcome to my video on the average rate of change of a quadratic function number 3. Number 1, we have a four-sided figure with 4 right angles, so we notice that this side is x plus 2 and this side is 3x plus 7. So this is the width and this is the length. So this is a rectangle. And we want to find the average rate of change in the area when x increases from 2 to 4. And there's several ways we can do this. We can say that the area of a rectangle is length times width, and the length is 3x plus 7, and the width is x plus 2. So multiply the length by width. Just by FOIL first. Is 3x times x is 3x squared. 3x times 2 is 6x. 7 times x is 7x. And 2 times 7 is 14. So to simplify that, we add like terms, 13x plus 14. So the area is a function of the width. So when x is 2, we can find the area by subbing 2 in the place of x. So it's 3 times 2 squared plus 13 times 2 plus 14. And that gives us, we square first. 4 times 3 is 12. 26 plus 14. And that's 40 plus 12 is 52. And when x is 4, then the area becomes 4 squared, 13 times 4 plus 14. And 4 squared is 16 times 3 is 48. And 13 times 4 is 52 plus 14. And that ends up to be, that's 90, that's 100 plus 14 is 114. So the average rate of change between 2 and 4 is, the average rate of change is the slope, and the slope is y2. So this point right here is 2 comma 52, and this point right here is 4 comma 114. So it's 114 minus 52 over 4 minus 2. And so that gives us 62 when you subtract over 2. So it's 31. So the rate of change in the area, so the area is in centimeters, so that's 31 square centimeters. And again, we're dividing it by centimeters. So it's the ratio, it's the rate of change, the ratio of the area to the value of x. So 31 is the rate of change. Number 2, we have a rectangular box, and notice that the base is a square with a height of 2x, so it's a rectangular box. Find the average rate of change in the surface area of the box if x changes from 3 inches to 6 inches. So the surface area. So let's call this face right here F, that's the front face. So we can find the F, and it's the front. This is a 2x here. So the front of this is a length times the width. So the length is 2x times the width is x. So that's 2x squared. And let's find the area of this side, this one right here. The side is the same. So the side is, the length times the width is 2x times x again. So 2x times x gives us 2x squared. And let's go with the bottom. The bottom of the box, the bottom B, and I'll call B for bottom, is again, it's a square. So it's s squared, or it's x times x, which is x squared. So The surface area is made up of the front and the back, so it's 2 times F, and it's the side, so this side here is the same as this side right here, so that's 2 times S, and the bottom, which is right here, X is a square, the top is also a square, so it's 2 times B, so that's 2 times 2x squared, 2 times 2x squared plus 2 times x squared. So that gives us 4x squared because they're the same, and 2x squared. So all together the surface area 4 plus 2 is 10x squared. So we have the surface area, so we want to find the rate of change in the area. So again, the area is in inches, so this is, if you think about it, this is inches squared as the dimensions. So when x is 3, the surface area is 10x squared, so it's 10 times 3 squared, 10 times 9, so the surface area is 90. And again, that's in area, so that's square inches. So when x is 6, the surface area is 10x squared, so that's 10 6 squared, that's 10 times 36, so that's 360. So when x is 3, we have a 90. When x is 6, we have a 360. And that's not meant to be, this is 360, that's not a degree. And so the rate of change in the area, the rate of change is 360 minus the 90 over 6 minus 3. So this is, again, like a slope, x1, y1, x2, y2, so it's 360 minus 90 over 6 minus 3. And so that gives us, you subtract, you get 270 over 3, so that gives us 90. So the rate of change in the surface area is 90, and the surface area is in square inches, and is divided by x, which is in inches. Again, it's area divided by the value of x, and the value of x is the length or the width. Again, is area divided by the length, or should I say the value of x. Got to be careful, because in the bottom of the boxes they're the same, but the height is different. So this is in relation to the x value. So let's put an x right there. Area in relation to the value of x. Okay, let's do another one. Third problem. I'll try to vary the types of problems. We have the problem, the h of t, which equals 2t squared minus 16t plus 40, represents the height of a hawk, where the height, h is the height in meters, and t is the time in seconds. So h is height, t is time. Height is in meters, time is in seconds. Find the average rate of change in the height from 0 to 3 seconds. So before we start all that, what we should do is probably look at a diagram where if we let h equal 0, then we get 2 times 2 0 squared minus 16 0 plus 40. So when the time is 2, the height is 0 0, the height is 40. So that means that if you think about it, it's 10, 20, let's put 40 right here. And so when t is, this is t, and this is height. So when t is 0, the height is 40. So look at it, that this is opening, because this is a positive 2, that means it's a parabola opening upward. So this parabola will do this because it's positive, it will open up. That means the vertex on this is a parabola because of, again, it's a x squared plus bx plus c, which is a parabola. And because it's positive, it opens up. So that means since it opens up, the arc starts here at 40 meters in the air and comes down and down, and then it goes back up again. So let's find how far it comes down. So we could go 1, 2, 3, 4, 5, etc. But if we find the vertex of the vertex is the time when we have negative b over 2a. So that's negative. So that's a, that's b, and that's c. So negative b is the negative of a negative 16 all over 2 times 2. That's a, that's b, and negative of a negative is a positive. 2 times 2 is 4. So the vertex is that time when t is 4. So t is 4 right here. And if we take the 4 and plug the 4 back into here, we will get, so if we do the h of 4, 2, 4 squared minus 16 times 4 plus 40. 16, 4 squared is 16 times 2 is 32 minus 64 plus 40. That's a negative 32, so that ends up to be 8. So the vertex of this parabola is t is 4, the time, and the height is 8. So at 4 seconds, which is right here, that's a 10. So it's about, let's say, just estimate it here. So the hawk flies down and comes to the lowest point, and then it goes back up again. So that's important because where is 0 to 3? So 0 is here. There's 4. So 0 to 3 is this interval here. Hawk is flying from 40 down to whatever 3 is. So what's the slope of this line? Well, let's put a 0 in. So the h of 0 is 2 times, which we already did. We put a 0 in before because I worked it out right here, be 40. So that's 40. So that's a 0, giving us 40. That's where it started off at. And when we put the h of 3 in, we get 2 times 3 squared minus 16 times 3 plus 40. And we square first. 9 times 2 is 18 minus 48 plus 40. And so that's 18 minus 48 is negative 30, plus 40 is a 10. So this is a 3 giving us a 10. So what's the average rate of change? Well, you can see that from this that it's going down, so the height is decreasing, so it's a negative slope. So the rate is 10 minus 40 over 3 minus 0. So that's negative 30 over 3. So it's a negative 10. And it's a negative 10, and that's the height. So that's in feet. Let's see, it's going, the height is, my mistake. The height is in meters, and the time is in seconds. So that's how fast. So we're leaving here at 0, going to 3. So this is the slope of this secant cutting through here, negative 10. So what about from 4 to 5? So 4 is when it's the lowest, that's its vertex. So this vertex is 4, 8. So this is when the bird hawk comes down and stops and goes back up. So it comes down and then it starts to go up at the vertex. So you're going from 4 up to 5. So you're looking at the slope of this secant here. So we found out what 4 was. 4 was an 8. We don't have to work that out again. So the h of 4 is equal to 8 because I worked that down here. So what about the h of 5? Let's plug 5 in. 2, 5 squared, 16 times 5 plus 40. 25 times 2 is 50 minus, that's an 80 plus 40. So that's 90 minus 80 is 10. So here we have 5 gives us a 10. And so what's the rate of change in the height? So the rate is, let's look at this point here, which is 4 comma 8, just write it as an ordered pair. Remember, this is t and this is h. This is t and this is h. So it's 10 minus 8 over 5 minus 4. 2 over 1 or 2. So the rate of change is 2 meters per second, going from 4 seconds to 5 seconds. And when does the Hawk stop? Well, the Hawk stops. Hawk is going down here with a negative slope. Hawk is going up here with a positive slope. So in between the two, it's right here. The Hawk will stop at its vertex, which is 4 comma 8. So at 4 seconds. So the Hawk will stop when the time is 4 seconds. Hawk will stop at its vertex. It's going down. Momentarily it stops and then it got to swing back up again. So 4 seconds. So the Hawk will stop at its vertex. Again, the path of this Hawk is the equation got a positive A, meaning the parabola opens up. So it comes down, stops, and goes on up. Just wanted to illustrate different types of problems. And if you like it, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content of my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.